Hi, Assalamualaikum. Today I will tell you about typical vapor compression aircon system in automobiles. Transportation vehicles are the one of biggest energy consumers. The extended use of the aircon system due to climate change led to a significant increase in the energy consumption. The automotive aircon systems are designed to control the temperature, humidity, and air circulation in the vehicle cabin for producing comfortable conditions. The task is accomplished by a number of major components such as compressor, condenser, evaporator, and expansion valve, and the secondary ones such as fans and sensor. A refrigerant circulates and experiences a series of processes along the refrigerant cycle. Okay, now I tell you the developments related to the circulating refrigerant. In the 1930s, the first category automotive refrigerant is R12 and R22 has been applied for the first time in automotive aircon system. This refrigerant has been used for about half of the century of their satisfaction for some essential requirement in aircon system. But in the 1970s, the environmental concern has been raised and scientists have found that chlorofluorocarbon have links to the ozone layer. So, it will invented and the predominant one was R34A. This alternative must have zero ozone depletion potential. Starting from 1990, the replacement process have been complete by 1994. However, in the rest of the world, the transition to R134 was not as fast in the industrial countries. Although the new set of refrigerant was not harmful to the Earth's ozone shield, it had to comply with global warming potential condition. And the GWP is must at equal or less than 150. Therefore, R134 does not fulfill this criterion because its GWP is equals to 1300. In the evaluation of the alternative HF 01234, YF and R152A had been performed by some investigators who have found that with small modification on the aircon system of current automobiles, the two previous refrigerants can replace R134A. Thank you.
Today, I will present about development related to the compressor. The compressor, which is the heart of the system, compresses the refrigerant sufficiently to raise its temperature above the ambient one and force heat to transfer out of the condenser. For design improvement, firstly, the primitive design of air conditioner compress was of reciprocating piston and crank type. The piston is connected to a crankshaft which is rotated by an engine pulley. The arrangement were in line or V-shape. Second, the initial design has been discontinued due to its heavy weight and poor performance. So to solve this problem, many new designs have been developed, which is swash plate design, rotating vane design, and rotating screw design. For swash plate design, the first generation of this design is a reciprocating axial piston type, which is characterized by a swash plate and fixed capacity. Second, this improved type of compressor still dominates the automotive air conditioner market because its technology is mature and its reliability is high. For rotating vane design, mainly characterized by its compactness, quietness, and low frictional losses, it produces the greatest cooling capacity per unit mass of the compressor. For rotating screw design, it has begun to spread out in the market because of its distinguished aspect such as quietness, weight lightness, and ability to reach 100% volumetric efficiency. The most common compressor design that are used in automotive or air conditioner system. For design limitation and improve each type of the approved compressor, firstly, for the compressor with swash plate type design, it is noticed that one of its design limitation is the leakage through the valve. Regarding the compressor with rotary vane design, leakage and friction losses associated with the contact between vane tip and inner surface of the component are two main design problems of this type of compressor. one more design limitation which affect of the previous compressor design, reciprocating switch split type and rotary vane type is noise and vibration. Concerning the compressor with scroll type design, leakage and non-optimization of design are still two main limitations that prevent the design as well as performance improvement. Lastly, noise is another design limitation. So next, I will explain about development related to the condenser. The condenser in air conditioner system act as a heat exchanger and it transfer the heat loaded in the refrigerant to the surrounding. For design improvement, firstly, the design of earlier style of condenser made of copper and composed of series of straight fin tube which and connected together by loop has been significantly improved as many studies has been indicated. One of the studies has presented a diagram that shows how the condenser efficiency has improved with the design evolution, which is 1980 to 2010, from the serpentine type passing by the multi-flow type to the subflow type. Last but not least, has include a simulation model with a new subflow control and found that it has more energy saving benefit compared to a conventional control design. Consequently, the development condenser has changed from the tube and fin style to the integral parallel flow, receiver dryer style passing by serpentine and parallel flow type. For design limitation, firstly, an important design limitation that can affect the condenser performance is its fouling. Second, this drawback is investigated through the development of different simulation model. Lastly, also blockage of microchannel and repair problem of the condenser are two more design limitations that should be overcome. Thank you.
Hello, I want to share about development related to refrigerant controller. Okay, it will regulate the amount of liquid refrigerant flowing through the evaporator and contain mainly an orifice tube or expansion valve. Through the device, the orifice tube or expansion valve, the control takes place allowing the refrigerant to expand and the pressure to be lower before the liquid refrigerant enters the evaporator. It is important to mention that orifice tube have been developed before thermostatic expansion valves, and their first generation were of fixed orifice. After after that their performance has been improved using by a variable orifice in them. Also thermostatic expansion valves are improved later on to become electronically controlled EEVS or electronic expansion valve. The voice of an expansion device that satisfies both cost and performance constraint for SC system with alternative refrigerant for R134A is still an open issue. In this context, an important study has investigated different design with a controllable expansion valve and a two-stage bypass orifice for a prototype of a R744 automotive system. It's, it is found that the controllable valve increased the COP by 15% better than the two-stage valve. Also, a comparative study between capillary tube, constant expansion valve, and thermostatic expansion valve has found that the device offer maximum efficiency over a wide temperature and a load range. Choking flow in expansion valve has an important effect on their performance. A research team has developed a model to investigate the choking flow characteristic in EEVS, and the investigators have found that the range of a relative deviation between results predicted by their model and the experimental data present in literature is from -5% to 6%. Another study has traced the influence of the operating characteristic of and EEV on the operational stability of an AC system, and it is found that EEV evaporator control loop become unstable when there is a larger proportional or integral gate.
Hello, today I would like to present about developments related to modeling methods of automobile AC system. There are three types of modeling approach, which are physical-based modeling approach, which is a modeling of a system or its component is based on detailed physical relations for the sake of predicting the system performance. Second, data-driven modeling approach, which is modeling of a system is based on the employment of its performance data and the application of some techniques to predict the system performance. And third is hybrid modeling approach, which is a physical-based approach is applied to obtain the fundamental structure of a model, whereas the model parameters are estimated through some development algorithm which are based on system data. In hybrid modeling approach, there are two types of approach, which are whole AC system and individual AC system. For the whole AC system, model developed for steady state and transient operational modes. Second, it can predict for most of the system parameter was within 50% in steady state mode and its prediction to behavior of the city driving cycle. And model can predict the pattern of upcoming changes in the comfort level for producing reduction in the overall AC power consumption. For individual AC system, model developed for predicting the steady state performance of a reciprocating automotive AC compressor. And model is based on experimental data and it can discharge refrigerant enthalpy, the required compressor power and refrigerant mass flow rate. As conclusion, there are 5 key in this development. First is invention. The invention of automobile AC can transform vehicle cabins from hot to comfortable conditions during traveling in hot seasons. Second key is restriction. Some of restriction related to safety, energy efficient, and environment protection can make only few refrigerants meet the imposed attributes. Third key is improvement. Compressor change from piston and crank to several new types, while condenser, the parallel flow, microchannel, and integrated receiver is highly recommended. For the control evolution, future trends show that the advanced electronic type is the most attractive because it provides better performance than the other. And lastly, weakness. Higher energy consumption, extra fuel consumption, pollution and performance decrease at certain speed is some of the weaknesses that need to be taken seriously. Thank you.